Hello, everyone. Today we are going to be talking about compositions of functions. So before we get started, though, it might help to do a little bit of a review of some of the past transformations that we've learned. So I'd love if you guys would try the Ignite. Question number 1 is going to ask you to do a translation. And question number 2 is going to ask you to do a reflection. So pause your video now and give them a shot. All right, answers are up. For the first one, translations. Based on this rule, this one, translations are just a shift somewhere on the graph. So when we have x plus 5, that just means that we are moving to the right 5. And if it's a y minus 1, it means the graph is moving down 1 in this case. So when you do that, your image, make sure that you have your points labeled correctly. We want to make sure we use this prime notation because that lets us know that that's where the shape has been moved. On question 2, this one is all about reflecting over the given line. So y equals -1, that's the line that goes through -1 for y. So if we were reflected over that line, you would have got the image that you see here. Now, compositions, what we're talking about today, compositions, let's read our vocab word for today. It says that compositions are when we have 2 or more transformations that are combined to form a new transformation. Now, it's not forming, for example, an entire new one. It's just saying that we're going to be doing 2 different transformations on the same set of points. So, for example, if we look at example 1, this says the vertices of triangle ABC are as follows, what you see here. And it says we're trying to find the coordinates of ABC after this composition. So if we look at the first transformation that it's asking us to do is a translation. So let's start by plotting my points on the grid. Triangle A up here, that's going to be where I go right to up 1. So I'm going to plot point A, make sure you have the labels next to it. My next one tells me I'm going to go B, which is right 5 up 3. So B is going to be here. And our last triangle is point C, which is right 6 and up 2. So my triangle here, if I look at that first transformation, it's saying that we're translating this. Now, if we look at the rule here, this is basically telling me that I'm shifting to the left 8. If it's x minus 8, we are going negatively in the x direction, and x is from left to right. Now, remember, if there's nothing with the y, that just means my shape isn't moving up or down. I am simply going to take each one of these pieces and we're going to shift them left 8. So if I take point A, we're going to count 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And that right there is going to be my new location for point A. Now, what is the name of that point? That's going to be at -6, 1 is the first point. Now, if we do the same thing with B, I'm going to now count 1, 2, 3, 4, 5, 6, 7, 8. Point B, I'm going to shift to the left 8. And it looks like that point is going to be at -3, 3. Left 3, up 3. Now, remember, when we measure our transformations, to find the point, we always measure from the origin. But to apply the translation, we count from the point. So point C, I'm going to start at C and go left. Oopsies, left. Oops. Starting over. Left, 2, 3, 4, 5, 6, 7, 8. And that's going to be where I plot my point. But to find the actual ordered pair here, we want to make sure that we measure from, sorry guys, I don't know why that's happening. And we're going to measure from the origin. So to get to point C, I'm going to go left 2 and up 2. And we now have our new location. But what's changing today is that that's not going to stop. When we're going to find our new point right here, we are going to now take our shape here and we are going to now reflect it. My second transformation here, now I'm going to do this in blue, but what we want to do is we want to take our new shape. I'm not going to look at my original shape for this one. I'm going to look at the red shape and I'm going to take that shape and now we're going to reflect it. Now here's where the rule, obviously, for reflections, where are we reflecting it over? we are reflecting it over the x-axis. So think of our x-axis as kind of like the line that we're measuring all of our points from. Whatever the distance away from these guys are, we're going to count that many in the opposite direction. So to get to point A from my blue line, I'm going to go up 1. So that means to find the reflection, I'm going to go down 1. And that's going to be where point A is. If I measure B is I'm measuring, B I am measuring from this point right here, and I'm going to count up to 3. So to find my new point, I'm going to count down to 3 to find point B. And then last but not least here, hold on guys. It's freezing on me. There we go. So point B is going to be right here. And my last point to get to point C, I'm going to go up 2. So I'm going to go then down 2 to get to my next point for C, which is going to be right here. So when we find our new locations now I can actually list out the ordered pairs of my final composition. Point C, it looks like is going to be at -2 to -2. My next one is going to be on point A. That's where I go left 6, down 1. And then obviously point B, we're going to go left, looks like 3, and then down 3. So -3, -3. So when we can perform our compositions, we always take the new set of points, and that's what we use for our second transformation. Now, notation-wise, I did use the wrong notation, and I do want to apologize. For our next shape, when we do 2 transformations, basically each transformation adds a new tick mark to that number. So when we see the double tick, that lets us know what the second transformation did to my graph. So each of the different pieces each have their own notation. The not prime notation is the original. That on our graph was this one right here. The one that has the prime notation was where it moved after the first transformation. And then where it ended up with that, the double prime notation is the second transformation. So if we look at example 2, let's see what we got here. Now here it looks like we actually have a translation and then we have a rotation. So let's start by plotting our original points. My points A is going to be at 2, 3. So I'm going to go right 2 and up 3. And then point B is going to be at -1, 6. So I'm going to go left 1, up 6. And that's going to be where point B is. And now we're going to apply our first translation. For our rule here, this is telling me that everything is going to move to the right 2 and down 3. So each of my points, I'm going to now do in blue on here, but I'm going to take them each and I'm going to move them right 2 and down 3. Point B, I'm going to go, point B, I'm going to go right 2, down 2, 3. And this is where my new point B is going to be. Point A, I'm going to do the same thing, right 2, down 2, 3. A prime is going to be right here. Now, once I have my 2 points here, it looks like A is going to be at, I think 4, it's going to be at 4, 0. And B prime, it looks like we go right 1, up 3. So 1, 3 is my new set of points. And the red ones now are the ones I'm going to use to do my second rotation. Now for these guys, rotations, these are all about which way it's going. Sorry, guys. So for this one, for point B, it says we are rotating 90 degrees clockwise. So clockwise on a graph always goes this direction. So all of my points on my line are going to move to the right 1 quadrant. So point A is going to shift and it's going to go down into this quadrant. And remember with our points, anytime we shift, we always rotate the points for every 90 degrees that we go. So point A, because it's moving 1 quadrant, I'm going to flip my ordered pairs once, but then we match it to the coordinate that it's going to be in. If I move point A down here, that means that my next point A is going to be right here. And that means that the X coordinate has to be negative. That coordinate, it's always the first one's positive and the second number is negative. So point B, for example, point B is also going to move 1 quadrant. It's currently in quadrant 1, but when it moves to quadrant 4, First thing that's going to happen is my ordered pairs are going to flip, but then we match our signs. The first number is supposed to be positive and the second number is going to be negative. And I know that at this point, I'm going to go right 3, down 1, and that is going to be my new location. So what I want you guys to do now, if you guys want to pause and try example 3 on your own, here you're going to try doing first a dilation, and second on this one, you're going to do, or excuse me, first we're going to do a reflection, and second, you're going to dilate it. So pause your video now and give it a shot. All right, so I didn't put everything up. I only did the first transformation. And this one said we're going to reflect it over the line x equals -2. If you got point H to be at 2, -2, you would have been correct. X equals -2 is the vertical line that I have drawn on my sheet. So we count the distance away that that point actually is. So if I count 1, 2, 3, 4, H is 4 away from that line. So if I count 4 to the right, we find the final resting place of H prime. Now for the second one here, when we do our second transformation, we're now going to take H prime and we're now going to dilate it by a factor of 3. To find out where this new point is going to go, we multiply each of these quadrant or each of those coordinates by whatever the scale factor is. 2 times 3 is going to end up being 6. And -2 times 3 is going to be -6. So for my final resting place of the H double prime here, we are now going to count to the right 6 and down 6. And that is going to be where the final place is going to be. Now, if you guys would like to, I have one more you try now at the bottom. If you want to try, please pause your video and give this one a shot. Please do so now. All right, final answer is up. If you did not get what I got at the top or here, then make sure you check with your teacher and see if you can figure out where you went wrong. But if you did get this, then you can now move on and you guys can start the homework for the day.